Hello, hello. Hi. And we're back to working on the cast programming language here today. All right. What are we going to work on? That's a good question. Let's figure it out. I don't know. There's a lot of things that I could do. Figuring out what is the priority is a different thing. What are we missing currently? What is the most important thing that I'm missing? I don't know. Right now, all the types are anonymous. That's one thing. Another thing is that we don't have generics. But we do have like functions that operate on types. Maybe I don't need generics that much. Yeah, like I actually can probably do this. So over here, generic type int32, right? But int32 here can be actually inferred because we have the 1, 2, 3 here, which is an integer. I think the only thing that's missing here is the underscore, like an explicitly inferred thing, right? I just don't have the underscore, so maybe I do that. That is going to be really easy to do. Let's see. This is going to be explicit inference variables or something. Is that what I call it? I guess that's what I call them. Okay. So we have a to do underscore expression somewhere. This place. Yeah. I mean, technically, eventually I should have inference for values. Right now we only have the types that are inferable. So for now it is relatively easy to do it like this, like literally just like the type, right? So it's a new not inferred type. This is my value, and it's going to be a constant expression. I just don't create the type expression here. Why do you do it in OCaml and not in Rust? Hello, baby Marla. It's because the Rust has a lot of the compile types in Rust are bad, but I was doing it in Rust before. I literally am rewriting my programming language from Rust to OCaml right now. And the only reason is the compile times. I think that maybe is everything that I need to do. Restart language server. Let's see. Hello. Yeah, I think this works. There we go. So we can have actually generic types. We just make the explicit generic arguments to be underscore so that they are going to be inferred. That's all that's needed. Right? So that was easy. But like I said, I want to have inference not only for types, but for other things too, like the generic inference for values. If I want to do that, that's going to be more difficult. Do we have an example of a value that I would like to be inferred though? Usually when you infer a value, it's like for example, another size of an array. The other type of a value that we infer is going to be the context, but I don't do the context inference yet. By the way, I fixed the emojis. That works now on the playground. Wait, this broke. Wait a second, why did this break over here though? That makes no sense. uh Actually, this over here is the inlay hint. Okay, now it's gone. Oh, it's the old inlay hint. When I'm formatting, it's like keeping the old inlay hint there. That's what was happening. Okay. And it put the inlay hint in the middle because like the emoji is like 2 characters kind of, or 4 bytes. It put this thing in the middle of those. That's why it was broken. Okay, anyway. That works. I should try to solve some real world problem, right? Maybe, and then we will figure out what's wrong. Where do we go? I can go to like the Advent of Code, the old one. I heard there's like a new thing. I don't remember what it is. Something like Advent of Code. New thing like Advent of Code. It was like running recently. And then I don't know. I mean, I can just try the old Advent of Code. 24. Wait, did I not do the 2024? Oh, I'm logged out. Never mind. Yeah, I did not do much. I just did 8 days of Advent of Code. That was in old version of Cast. Actually, hold on. If I have the old version here, maybe I just try to use that. I try to see my old solution. And then I update it. Maybe that's what I should do. Let's see. Advent of Code 2023, 22. No, 124. Over there. Advent of Code 2024. So let's see. Here is the solutions that we had previously. And it's not going to work, I'm assuming, anymore. But let's see why. Yeah, I see immediately that I'm already using generics here, so maybe and lists, right? Read files. Read file is easy though to do, I think. We just expose it in the standard library. Okay, I mean, sure, let's try that. Let's try that. I want... okay, so what I want is... what I want is... maybe just copy this here. Let's just do advent... Let's do this in the examples folder here directly. Advent of code. 2024. J1. Part... I don't know. A new file, J1KS. Let's do that. Let's do that. And then in the workspace, I will do examples. Advent of code 2024 J1, so that it works. Okay. So the first thing I can use, not use .star here. Use import this .star. I don't think I need the utility here. We just import prelude like this. Okay. All right. So the first thing that we need to do is to be able to read the file. I think this should be std IO read file. Or should it be like stdfs? Should it be a separate module file system? Maybe. Sure, let's do that. Trying to solve and code 2024 J1. Okay, stdfs is not there, so let's make stdfs be a thing. I guess it should be somewhere over here. Fs. Why do I have a colon underscore here? That I think is unnecessary. Fs mod like this, but that's not going to work because I need this file to be available. Fs mod. Okay, there you go. So this is a module, and we have a read file, which is so for now it's just going to be just a function from string to string. Sure. Which is going to be path into CFG if so read file is just going to only work for interpreters. for the interpreter, and it's going to be a native file system read file path. Let's do that. Okay. So now if I try run examples, advent of code 2024 day 1, it's just going to say that there is no native like this. I just need to implement it on the OCaml side. J1 input txt. Is that how I do it? J1. I think I'll just do the example here. For example, this. There. And input. Just try just printing it for now. Reading it and then printing it. At file system B. Types fs. Okay, I'm just going to have over here read file. Read file is native function. Argument is a string. Result is a string. Name is read file, fs.read file, I guess. And implementation is going to be a function caller argument returning value. So we say that argument is argument value expect string option unwrap or else. Return error, value.error. Don't have that. I guess I just match argument shape with string path and something. If anything else, then I return error. Pass read file expected string argument. Over here, if I have a path, how do I read files in OCaml? How do you read files in OCaml? Open in Read file. Open in. How am I doing this for like imports, for example, or includes? Is source read. I have effect perform a read URI. Which works like this. If source read URI, read from file system. I think I can just do read from file system. Always there. Read from file system path. Let content be read from file system in shape is the string content. I'll just do this for now. This is good enough. So if I try running this is probably just going to panic because it's going to say that day1 input txt, no such file or directory. And because this should be like, because this is relative to the current working directory, not to the file, right? So I'm actually wondering if I want to support something like read file, right? Read file this. Um, I can either try to set the current working directory to the path of the file. Or I can ignore this issue and no, I don't want to ignore this issue. Let's actually see, how do we set the path? Camel std_lib. Is there something like current working directory? It's sys. Execute given shell command, return exit. Okay. Time, change directory. Change the current working directory of the process. I think this is what I want. Which also means another thing. Let's also call this sys. Right? And I'm going to have similarly. I'm going to similarly have over here that change directory. This is going to be just string into unit. The function path into the thing, and it's also just like the files works only for the interpreter. Maybe I want to improve this. Because this is a little ugly at the moment. We'll see. Native fs read file. Native sys dot change directory path. Okay, let's do that for now. So what I want is I want std sys change directory, and over here we want to know what is the directory of the current file, right? So we need to have something similar to like underscore file. Is there like something like underscore dir that should be set whenever I'm parsing a file or whatever? Maybe change dir to the directory. We can also just expose the file. Hello, Nigel. I can also just expose the file. This is the current file being processed, right? And then we could have another function which takes the directory name, std path, then, right? Std path directory name of this. And we change the directory to that. Sure, let's do that for now. Directory name, string. For now we just use strings for everything. Cast shebang. Yeah, I just copied the Advent of Code solution from last year. Advent of Code did not start yet. No, I'm just trying to like, this is 2024 one. I'm just trying to see how much am I missing from the language to do that. So dir name is string. As a function, path, generics. Yeah, generics are technically missing, but like I said, like I was saying yesterday when I was finishing the stream, we don't technically need generics because we can have just functions, right? Over here I have a function that takes a type t and returns a new type, which is like the struct, right? And then we just say that foo is this thing where this is a generic type with this argument being inferred. It's just a slightly different syntax, kind of. Polymorphism. Well, that's going to allow polymorphism, yes. That is what is allowing polymorphism, right? There is one more thing, which is the... can you write ID? Yes, you can write ID. You can write ID. It's just a function. So like ID is a function that takes t and returns t, right? Which is x into x, right? But what is t? What is t? T means that it's a function that takes a type and then returns this type. Oh, I guess we cannot like write it out actually. I cannot write the type out. Actually, yeah, I'm wondering if we can do this. Let's see. So the idea is that it takes the type t, and then it returns the function that takes x of type t and returns x, right? There you go. So it's type into error into error. Okay. I guess it doesn't work like this. I guess it was not working like this with functions previously either, right? So generics were a little bit different in that sense. Yeah, it makes sense because this over here it was not a value. This is at this point just a binding. Yeah, that makes sense. So this is basically what's called the dependent type. It's a dependent function because the type of the result is depending on the value of the argument here. Maybe we can try looking into that and do proper dependent types, and then we don't need generics technically to be like hacked. Okay, we have the path. What do we write here? I just implement this in OCaml for now. Or do I actually try to implement the directory name here? If I can implement that in the language itself, that would be nice. Right? So kind of just want to find the last slash. All right, fine. Let's see. But for that, I will need to implement other parts. How should this work? So path is a string, right? I need to find the last thing. And in order to, when I find the last thing, actually, I want to return an option. Is it possible? It's currently possible to do dynamic typing. I don't know. Was it ever possible in cast? I don't know. Well, I mean, technically, you can ignore the type checking errors, I guess. And the program is still going to run. So kind of. Do you need dynamic typing? Maybe I just do like you know, slash index is string dot index of slash in path, right? Okay, then we return path or whatever. Types don't have fields. So now I need to have a module string and implement index of, right? Let's have a module string. I'll just have it here directly for now. And then I say index of is a function that takes a character and string and returns an integer. which is the index. Is module just library binary separation? No, it has meaning. It is introducing a recursive scope, technically. So that the things inside of a module can refer to each other. Instead of only being able to refer to the thing that was declared previously. And this also... this also... is reminding me that I don't have the characters right now in the type system, so we will implement that, I guess. Okay, there's a rabbit hole. We're going to implement a lot of missing things here, I guess. So I just index of C, which is character, in a string, which is a string. This thing returns an integer, and this over here is the body. I'll just return 0 for now. So yeah, this says that char is not found, right? Type check failed. This is not integer. Yeah, so I need to enter this, that, and that, right? There we go. Okay. Right now, single quoted strings are also strings, by the way. I guess I'm going to change that. So string, this, I need to implement a char, which is a type, which is native. Char, let's do that. Okay, natives. I need to do char is tchar, which is not available right now, so we need to do tchar, and we need to do vchar, char, and then when I print, oh, I forgot to do LSP support. So yeah, when I print value shape, if we print a char value, then we print also green, I guess. %C value. Okay. Print type shape. A char is a char. Cast types, and the type of character is the char. Over here I forgot the bracket. In the inference, we need to say that characters only match with themselves. And to do OCaml AST char value, I think. And when we do completion, if it is a character, then it is just like other variables. Okay. So that works. Okay, let's see next path. Restart language server. Okay, so now the char is a known thing to the compiler. Index of this. This now type check is failing. Char is not a string because a single quoted things are still treated as strings for me, which means that I need what in the compiler. Cast compiler. I don't know where. Yeah, I guess this is it, right? When I have an expression and we have a string, then it's a constant of a string with this constant, with these contents. That's right. So I need to check. So string is a string shape. It has a row and it has contents. String shape. Let's see. This is the lexer. And to see the lexer. We have a read string implementation. Delimiter is C, which is literally just the first character, right? Read string impl is being used over here. I think my tokens, which are strings, should have also the quote delimiter. We just have delimiter as a string here stored, which means that over here we just have the delimiter char to how do I convert character to string? It's just a string make one delimiter. Okay, maybe like later we'll have delimiters as like multiple characters or whatever. We'll see. So now in the compiler, I check over here, right? If I'm going to match string delimiter, right? If it is the double quote, then we do the constant of this string. If it is anything else, we say v error. This is a value shape, not of char. Is there a string of char? I don't know. No, there is no of char. There's of bytes and of sequence. Because it's OCaml. They only have the bare minimum, which is okay, I guess. If it is this quote, then I do a char. But the contents then must contain a single character, right? So I say that if as contents string length is 1, then it's a character of string String get s0, right? And else it's going to be an error. Let me do over here. This is going to be span AST span. Unexpected delimiter. And in this case, before returning error, I will say char literals must have a single char. Right? String get returns an option. Yes. Option get, because I checked the length already here. Okay, there we go. I think this should fix it. Path. So now this is a char. Index of. Now I need to actually implement the index of character in a string. Let's try implementing it in the language, like in some stupid way, right? So I want a loop here. I want a loop. A loop. I want a while. I want a for, a range technically, but we don't have fors yet. So I think I will do. Let's try to do. All you need is fold. I guess all I need is fold, yes. Fold is going to be like a native function, right? I guess. Sure. Sure, let's do this. So we need a function fold, right? This is a thing that takes a function, which is a this takes a string and a function which takes a character and returning nothing, right? That's not fold. That's just function iterate, I guess. Kind of. Although we want it to be different later. Yeah, the actual fold, which has like the accumulator, should be done with generics. So I think the iterator is the easiest thing. We just we iterate using this consumer. And this one is implemented natively, I guess. Okay. This one I implement InnoCaml. Going to be string.iter. This returns unit. So I call this using sure. So then index of is going to be implemented how? Right? We do s. We do iterate string using the consumer. What's the variable name that should be here? Also, we kind of like want to the iter_i function, right? First, iter_i is a function which takes a string, and then a function which takes both the integer, which is the index, and the character, right? And that's going to be having let index be 0. I don't have mute here yet, right? So it's just always be mutable, I think. Now you don't need native iter. Why do I not need the native iter? Because iter_i is going to be implemented using the iter, right? That's what I'm saying. So I just iter s and then c into f I c, and then I is I plus 1. Native iter_i is more useful than iter. Do you think this one should be implemented natively? And this one, so like it's like the other way around, you think? I don't think it matters really, right? Maybe because like iter_i is something that is more often used, having this implemented natively is better for performance. I don't non-native +1. Do I have it? I think I do have the plus operator. Yes. I'm not sure though if this is going to work though. That's what I'm not sure about. But I think it should work. I don't remember that I tested the mutation like this yet. Maybe I should just try a simpler example first. Let's return 0 here for now. Let's try it in hello world. Let's try this. Let x be 0. X is x plus 1. I cannot even like wait, no, I have int32 to string function, yes. So I just print int32 to string x, right? Let's do this. Cast run examples hello. It did print 1. But it could not find the std here. Okay, that makes sense actually. So I cannot use the plus. So what happened? Is standard library was not like this is the error that is technically not here, but the thing that I was just writing in std path, right? Over here we have a plus. The plus is just a syntax sugar for calling the operator add. But it is syntax sugar for std op add, and inside of the std symbol is not defined, which is a little, yeah, I need to kind of like figure out how to do that. Because for the same reason, as you can see this over here, target name is interpreter, I'm just doing native equal instead of just doing target name is equal to interpreter. This makes it more ugly. So in order for this to work, I just need to say I is like native plus I and 1. That's going to work, but I is I plus 1 is not working right now. And to figure out how to do this properly. But yeah, this says 1. What I was wondering though is that if I do it inside of the function, right? So let's have a function inc. A function inc is taking nothing, and then just it it just increases the x, right? So then I call the function increase multiple times, and let's see if this works. It seems like it does, right? Okay. Yeah. It does seem like this works. Okay. Let's do this ugly way for now. It's okay. So index of is I need to iterate with the index, right? We iterate string, and then we have index and character at I, right? So then I say that if C, so this also should be right now native equal equal. If they are equal, the C and C at I, then I return, and I don't have returns yet, but I do have unwinding. So we have unwindable block. So we unwind the block with value I, and else. I don't need an else, right? Okay, something here is not working. Trying to compile error node. Unexpected if. This is unexpected. Maybe because of priorities, I need to have this inside of parentheses. Unexpected closing bracket over here. Unexpected closing bracket. Wait, which one is unexpected? Maybe I need an else. Oh yes, I do need an else right now. Do I not have the if without an else? Syntax, default, rules. Yeah, right now I need the else case. Well, I mean, don't I just implement if without the else case? That breaks. Fatal error, expected names. Okay, the current implementation actually requires the then case. In the core syntax, I guess. If I can change that. Mm. Mm. This is by the way type expression, and this is pattern. Let's just keep the else case for now. I think that's going to be done later. Okay. The type check failed. Int is not a unit. Yeah, so iter I is returning a unit, right? But we need to actually return the integer, which means that this should return -1, I think, in the end. Wait, -1 doesn't work? Because I only have the binary minus? Okay, I don't have the unary minus sign right now, and like the lexer... Yeah. Let's say 0 - 1. That would work. Which also right now needs to be native minus 0 and 1, which is okay. Let's make it work first, and then make it look nice. So index of Let's try the let's also move this string into its own thing. Const string is include string. Right? I think path must be included earlier for this to work, but I'm not sure. Let's try in hello world to use the index. Right, so x is a string, std string index of slash in hello slash world. No field string there. I mean, technically it's there. I just need to restart the language server, right? Yes. Okay, so this is supposed to work, but I think I did not implement the string iter yet. So let's do that. String iter, that's in natives. Mod string. Mod string is iter, where iter is native function. It's a native function where argument is a string. No, not argument is not a string. Argument is a tuple. Let's actually like make not inferred. Because I don't want to care about this right now. Where is the syntax error? It's because argument is this. Will this path thing support unicorn emojis? Hello, John Anderson. I fixed the emojis. It works now. Look at this playground. There is emoji here. You can run. Let me remove this. Just print emoji. So just welcome to the guessing number game, and instead of this smiley face, we just do a unicorn. Run. Look at this, a unicorn there. And the formatting also keeps it. I fixed it. Hello, Brainoid. A constructor has type. It sets there's a syntax error, and I hate that it's like telling me the error in the wrong place. If I comment this out, there is no syntax error. If I don't comment this out, then there is a syntax error, but I don't see it. Am I blind? Did I buy your game yet? Is it expensive? I'm broke. Steam needs to update apparently. Hold on a second. Bum 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 bum. Hello, Steam. Are you here? My Steam is broken. Exit code 0. So we just exited with exit code 0. I don't want it to exit. Hello? I think this new window manager that I switched to is breaking. Oh wait, now it showed something. I think it just breaks. It's weird. It was working earlier. I have no idea. Yeah, there is like an issue. I'm sorry. I'll buy your game later. Is there a lot of people playing it right now? It was a popular upcoming game, right? Replicate. Not many on Twitch at the moment. Yeah, looks like there is not a lot. But there is one Baldy. The Baldy. Bam 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 bam. The Mr. Demon Wolf. Hello, hello. Yeah, I have like the issues with this since I updated my system to this new window manager. Wait, I think wait, did my VS Code crash too? I had my VS Code open and it's not open anymore, huh? I think Steam broke my thing. It did. Look. When I try running Steam, it closes my VS Code. It's literally crashing it. All right. So I guess a classic Linux in action because it's not activated, I guess. Maybe I should activate it one day. All right, I'm just going to keep working on my language here. I'll play your game when I figure this out. Is there a lot of changes from the last time I was playing it? You gave me like the access to the beta, right? Is that much different? I probably still am really bad at the game. Wait, what was last time I played your game? I couldn't beat it because there was a bug or something. I remember now. I was scammed of a win. Yes, yes. You gotta activate Linux. Linus Torvalds needs some cash. But what about my cash? I also need cash. All right. Let's help Movieman, find the syntax error in this code because I am blind. Where is the syntax error? Semicolon. Semicolon is the syntax error. That makes sense. Okay. So I have this function which is called string.iter, and the implementation is going to be function caller argument return value. I say that argument is value expect a tuple. I want to do with return here probably. Expect tuple option wrapper else error. I say let error be return shape is v error error color there was error in string.iter. I don't do many details here. This is good enough. Okay, we have an argument which is a tuple, and we say argument tuple unwrap named 2, unwrap unnamed 2. Okay, we're just going to panic for now if the types are incorrect. Let string and function be this 885. Is that the activation code? So these are 2 fields. Okay, then we do s is s value expect a string and get. Okay, let's just panic. Oh, let's do unwrap or else error. Actually, if I don't like unwrap and name 2, that would be nice. Can I like try? There's a thing that's called unwrap. Let's just before unwrapping just check it. If argument tuple unnamed length is not 2 or argument tuple dot is unnamed 2. How about this? I just make this function is unnamed 2. Sure. Let is unnamed length tuple is match tuple if tuple named list length is 0 and tuple unnamed array length is len. That's what I want. Okay, if not, then I error. There we go. So now I can unwrap easily. We have the string, which is the s, and then f is going to be value expect function. Unwrap or else error. Okay, we have this being a function, and I just call it. Hello, Veldak. I think we do this s into string dot iter, and then I return the unit value back. Over here we have a function c into c value is char c, and then I just want to call the function f. Which means that the native function should actually have the access to the interpreter state too, right? So that, yeah. We have interpreter dot I need to call a function. Let's see how that works. Interpreter is over here. This is the thing. Apply a function. Apply a function. This needs to be extracted into a function so that I can call it. And also I need access to the interpreter state to be able to do that inside my native functions. So native functions should also have the implementation native function over here, right? Native function is this, a caller span into value, right? But it should also have the state, which is interpreter state, which is not here at all, which means that it needs to be moved here from this place. State is interpreter state, and this is natives. Oh my god, I'm stuck. I need to move everything now. Well, I guess it's not that difficult to move that. Let's go to types. Interpreter state is this. Scope T is just interpreter scope. Natives is natives. And then natives is this. Okay, I guess that works. Now interpreter natives. Last interpreter. Scope is state.scope. Unbound record field scope. I hate this. Hate the way a camel does this. I know that this is a state and it has the field scope. This is already okay, I guess this is not annotated. I need to actually annotate it. Yeah, sure. Even though I have the type in scope, I don't have the type definition in scope, I guess, which is why this has been stupid. Okay, whatever. This compiles right now. Okay, I need to change the way the natives work. The native function, I guess. Native function. It also needs to have the interpreter state, which is interpreter state, like this. In addition, okay. So now I need to have this function color state. I'll just go into ignore the state for now everywhere. So yeah, when I call this, I need to give it the state also. All right, so this says that there was an error in the std iter, in string iter. Which error is that though? String.iter. Maybe I actually have a message here, and this is just going to be a message. Arg error in string.iter colon message, like this. This arg must be tuple expected to unnamed fields. This expected string as first argument, and this is expected function as second argument. There we go. Now I can at least know which error is that. Argument must be a tuple. That's right. Native string iter, S and F. But it is a tuple. Hello? Log info. Send a value print argument. Value is hello world and then a function. Yes, it is a tuple. Okay. Expect tuple says that this must be a tuple. Yes. And it is a tuple. Why am I even having this error then? That makes no sense. Now that makes no sense. Hold on. Because this literally is a tuple of a string and a function, which is exactly what it's supposed to be. Is it because I'm meshing on shape, which may not be a tuple? I mean, the shape is a tuple here, right? Exactly. Because so this over here, right? I have printed my value. Printing the value is just printing this the shape. Right? And the only thing that can print this is if the shape is a tuple, I'm pretty sure. I mean, it looks like a tuple here, so it would be weird. Inside expect tuple. View tuple. But when I'm printing, I'm also like matching on the shape, and like this is a tuple. I mean, let's try matching it manually here, maybe. Yeah, let's like match arc shape with like this, log other, and if it is v tuple, log I'm a tuple, right? Let's just try that. Oh, this can only be called once or not? Yeah, I think I cannot do it like this, unfortunately. Log. Let's just do println, whatever. I'm a. Yeah, I am a because I did not finish the tuple here, but I am a tuple, right? Because this is printed. Yeah, see, argument shape is a tuple. So when I expect a tuple, I am matching the value shape. This should return some value, right? Is unwrap or else buggy? Oh, wait, I know why. This is actually weird. It's because this can return anything. I don't like this. So here's the problem, right? The error is a function No. Here's the problem. The error is a function. As you can see, this is a function that can return any type. Why can it return any type? Because this function actually never returns. Because I'm having a return here, right? So because of that, this type checks, even though I would like it not to type check, what I have to do is to pass a lambda here, which takes a function and returns error. That's what I need to do. You know? Or I can make, I guess the easiest way is to return, is make error. Actually return a function. Or I guess error message and this. So it's like partially applied there. Yeah, I don't like that. I should somehow fix that in my language. So like Rust has a dedicated never type. And I think in Rust this would not type check. I can actually try. So let's try this in Rust. That's why Rust is better than OCaml. The one of the examples, right? So I can have a function foo. This function just returns never, like this, you know? Like panic, for example. Right? So, and then we want to have this. Let f. Yeah, and then I like call another function. Then I call another function f, which takes as an argument a function, whatever, something like this, right? So I want to call function f using foo as a function. Using foo, calling foo like this, right? Yeah, there we go. We expected a function closure, but we found a never type because a never type cannot be coerced to a type. There you go. But this is a problem in OCaml because in OCaml you don't have a dedicated never type. You just have a polymorphic function that can return any type instead. For the that's how you type the things that can never return in OCaml and in Haskell too, I guess. Which is why this compiles and doesn't give you an error. There you go. Rust is better, easy. But let's continue suffering in OCaml. Okay. It's a tuple, but the language says it's not. Whom to believe? Yeah, it was not saying that it's not a tuple. It's because this was calling the thing immediately. That was the problem. Okay, so now the answer is -1. The reason for that is because I don't actually call the function here when I'm iterating the string. Let's try that. So now I need to be able to call the function that is my second argument here as my thing. And I need to have something like this. Call I need to just call function argument and state an expression data span. And state so I want to have a function that is called call somewhere. Where do I put it even? Maybe like common ML here. Let's call span state function and argument is this. Right, span is span, state is interpreter state, function is value, and argument is value. This thing returns a value. Pattern match needs to be extracted now too. Pattern match. Eval. Wait, that's impossible now. Oh my god. I have the recursive dependencies again. Well, I guess I just move everything from here. Technically. The only thing that I don't move is the init, because that is depending on the natives module. So I move everything else. Is that it? And I just over here just include common, but I probably need to like rename it into something else. Oh, this is just state then. Internal path is dangling. What does this even mean? There's an error actually here. Eval. I think these functions, all functions must be recursive. That's, yeah, we need to do recursive pattern match and call, and assign, and eval, and this and this and that. Yeah, everything is recursive. Nice. ast.t. Move this here. Unbound value expression. Did you mean exp? Oh, because this must be just span now. Okay, that makes sense. Enter scope. Should also be over here. And now we have this. This variant parent is expected to have type exception. There is no constructor unwind within the type exception. But why? That's not true. Oh, it's because with unwind. Oh, unwind is an exception. Where is it defined? Exception. Exception. Unwind. Or did I remove it on accident? Unwind of... Ah, it's over here. Yeah. This must also go into the common module. Makes sense. Okay, success. Now that I have moved everything. So when I do the native function now, the natives can depend on common, right? So over here we say common dot call. Span is going to be caller. State, which I don't ignore over here. And we have our function. So the function that I'm going to call is just f, and the argument is going to be c. That is going to return unit, and I'm going to ignore the result here of calling this function f. F is value tuple field. I guess just say f.value. Okay, let's see if that works. Run hello. And it works. I think this works. So examples hello is right now I'm trying to get at the index of a slash in hello world. And the index of a slash is 0, 1, 2, 3, 4, 5. Yes, it is 5. Okay, I think this works. So this is now implemented in the language itself. And I was doing that so that we can have the directory name. And in order to have the directory name, I need to have like this. Yeah, I need to like have a string. I need to return string dot substring path slash index. And from 0 to slash index, there you go. That's what we want. I think this is the last missing part. I need to implement the substring. Substring will probably also need to be implemented in the language itself. So substring has the argument string s, the index, and is it the length? Start and length, int 32. This is going to be string dot length. No, not string length. String dot substring as start length. Natives string substring. Okay. Substring. So substring argument must be a tuple. It must have 3 fields. This string, start, and length. This must be a string. The second argument, start. Expect an integer. Expected start be int 32, and then length is length value, expected length to be int 32, and then I just return the string, which is string dot sub as position length. So we literally do the same thing, right? As start and length. But this must be int 32 dot to int 32 dot to int. Okay, this should type check fails. String is not unit. Substring should return not unit. This thing should return a string. I didn't type it properly. Okay, examples hello. We can try print. We can try write print std path dir name of hello/world. Expected 2 unnamed fields, got 3. Wait, where? This thing? Wait, why did I say expected 2 unnamed and got 3? Oh, it's because this actually is buggy. Okay. There we go. Unnamed is 3. Makes sense. Found a bug. Okay, there we go. And this is hello. Okay, nice. Dir name. And the reason I was doing this so that we can have the dir name of file. And the Kvi. No, no idea how to pronounce your name, but hello. What is the effect with particles you're typing? Is this extension? Yeah, it's called power mode. Power mode plus. Wait, there's power mode and there's power mode plus. That's a new one. This one doesn't have a lot of downloads though. This fork includes fixes and enhancements based on the community contributions from the original repository. Yeah, I'm using this one. But I reduced the shaking effect a little bit. And there is also this counter that I also removed. Okay, I think the last thing that I want before I commit is this file, maybe? Thing. Let's have a... I guess this is like a core thing. Then to implement into the syntax. Into the syntax. And have a syntax core __ file. This is literally just file. Right? So this is just going to say that there is no core syntax now, but it is parsing. And in the core syntax, __ file. Core syntax is a thing which just takes the span. Well, I guess this must be an expression, right? File must be expression. But if it is an expression, then we just give it a constant. I just give it a constant. Shape is a string, which is span dot Yuri, which is the file name. But I need to do Yuri to string, I guess. String, like this. Okay, now the question is this going to work? There is no core syntax file. Over here we do capital letter. Over here I do lowercase because there is a file in OCaml. All right, file is a string. Change directory. Let's try running this now. So if I do cast run examples, advent of code, no native sys change directory. Okay, that's the last thing. Okay, hold on, natives. Fast sys sys is going to have a change directory. Sys change directory. Since change directory has a string, this thing will return unit. We have a path, and then we just do sys dot change directory path. Then we return unit. File examples, no such file or directory. Oh, because it's a URI, right? A URI starts with a file. I need to like just get the path of it. Over here, it's not just a URI to string because URI path. Okay, now it says that day1 input txt is still not a file. Because I need to do day01. That's right. Day01 ks and day01 input. When we run this. Day01 input txt is still not... no. Dir. Let's do this. Let dir be this. And then print dir. At least seems like my language server is also broken. Yeah, it says their name is examples actually. Oh wait, I know why. Wait, I'm stupid. It's because directory name is implemented incorrectly. Path. It's not the first slash, it's the last slash that I need to find, right? And to find like last index of slash string. So this is index of, and then I need to do last index of. Right, I just say over here result -1. Result is this. I just iterate forward then, and I don't use unwinding. I return result, and over here I just say that result is equal to I. Otherwise I would need to implement reversed iteration. Okay, there we go. Examples, advent of code. This is my actual folder. And this is the contents of the file. All right, that works. That was a lot of things that I did right now. But we can read files and a couple of other things. Let me undo hello world, but everything else can be done. Read input of advent of code 2024 day 1. Okay. So now in order to continue solving the advent of code, we need to not only Okay, first of all, I don't want to figure out where's my language server broken. Oh, I know why it's broken. It's because I changed the file, so in the workspace, continue this because I don't automatically detect the files that need to be like parsed by the LSP. Okay, so I read the file, right? What is next? Next, we need to read the input. In this, we have the a lot of lines with two integers in it, right? We have two columns of numbers. So we just go over the lines of the input. Okay. I don't have fours yet. So let's do same as the string iteration by passing the function into the thing. Let's try implementing string lines. So I think it's going to be something like this: std string dot lines of s, and then we give it a function that's like line and then print line, you know. So we print every line separately. Something print line, print this, something like that. This is input. So std string, and then we want to have lines, which is a function that takes string, and it takes a function which is a string into unit, and this returns unit. So I think I can implement it in the language itself without it being implemented natively. Or do I fix this first? So I just do iter with index of string, and then I give it the function that takes index and character. And then I would say that if c is equal to if equal c and slash n, then I do something. Otherwise, I don't do anything, I think. Then end line. Else nothing. Trying to compile error node. What's the error? Expected if. Yeah, I need to like enclose the body of the function in parentheses, right? Like this. Yeah, so and then I will create a closure here, end line, which is like this, and then we will call another end line in the very end in case the string does not end with an end line, right? And then I just save the start index here, right? I save the start index here, and then whenever we encounter the end line, I say that line is a substring from of s from start to I minus start, right? So this has an I as an argument. So I call end line with I. What do I call it with in the end then? This means that I need to have the string length. Having a string length would be nice to have as a built-in, I think. Const length. String returning integer is string length s. Let's just do that. So we end line with length of s. So this is line, and then I just call the function f using line. And then after that, we also say that start is I plus 1. We cannot do plus yet, so we do native plus I and 1. Yeah. I think that's how we do lines. No native string length. But it did print the lines properly, right? Even though there is no native string length, the code before that executed properly. I think it just doesn't show me the last line. Yeah, the last line 3.3 is not shown because there is no new line in the end of this file. Nice. String length natives. Mod string length is a native function. String length, this takes a string and returns integer. State can be ignored here. String length argument must not be a tuple. I just say as is argument, expected string as argument, and then I just return the int32 dot of int string length s, and then we expose it over here. There we go. We can read the lines. Nice. String dot lines. Okay, maybe before going forward though, it seems like this is a little bit annoying right now, even though it works. The annoying part here is basically, instead of saying I plus equal 1, for example, we say this native plus. The reason why it's not working, once again, is that if I say I is I plus 1 here, like I want to, and it's going to say that std is not found because I plus 1 is just a syntactic sugar for std op-add. But std is not defined when we are evaluating code inside std. So how do I do that? Like, I need to actually be able to refer to the std from inside of the std. Let's have the minimal example. Of that in hello world for now. So here's the problem, right? I have let's say foo is like a module, and I mean this like std, right? std2. Then I have a thing here like you know, function foo is just a function that does nothing, right? So I can call this function here, but what I cannot do is I cannot do std2.foo. This does not work. It works from the outside, but it does not work from the inside, right? So in a language like Zig, this is solved by something like const like std2 is at this. So maybe I do something similar to Zig, where I can refer to like the current thing by having this keyword. But it also means that I must have this like as a value, which I only construct in the end of the scope currently. So I need to change how things work. I need to change how things work, and how do I do that? So a module is basically converting all of the local variables from a scope into the fields of the resulting struct. That's all that it's doing. So right now, the struct only starts existing in the end. But inside of this, since I don't have the value, std2.foo should basically be same as foo here, kind of. Is what I want, right? Yeah, that's what I want. Which means that std2.foo should not be like the actual field in access, but just refer to this binding. I can have like a fake thing where this is like a special kind of value. It's like a scope, right? This is basically just a scope here. You know, it's like current scope dot foo basically is what I want. So I need to have a reference. I need to have like scopes as values. And then whenever I'm compiling the expression, when I'm compiling this expression, I check the type of this. If the type here is a scope, then I do some like special handling here. That could be an implementation. What if in the future I also like kind of just want to have recursive structures, right? So if I have like struct with a field foo, you know, with a field f, for example, is a function that's called like g, right? And g is a function that's called f. It's kind of like similar, but we just do the fields directly here, like a recursive struct or whatever. In this case, it's not a scope because it's something different. Or I can like just not have this because this is achieving the same, I don't know. I think I'll try going with this idea. Have scopes as values. And the scope would be the compiler scope. Not the interpreter scope, right? It only so that we can refer to the bindings here. Okay, so I think in order to have this implemented, in order to have this implemented and current scope to be kind of like also a built-in syntax. Current compiler scope. Current scope. Let's just do that. Core syntax. Current compiler scope. So okay. Sure, let's say current compiler scope. So current compiler scope must be an expression. And we return as dedicated value, which is the current compiler scope, right? So we have a compiler. Compiler has a state, and state has the scope. And that's what I get into a value. Compiler scope is here. So I need to have a new value, a new kind of value. Value compiler scope of a compiler scope, right? And we have and we have a type compiler scope then. Value compiler scope. Compiler scope. Type compiler scope. Compiler scope. Let's have colors here, it seems. Okay. And we have type of over here. If I have a value compiler scope, then the type is compiler scope. Inference just says that compiler scope. Core syntax. Yeah, so now in the core syntax, the current compiler scope is going to return me a constant, which is a value compiler scope. Value compiler scope, which is going to be c state dot scope, right? And then over here I have a typo. Compiler scope is not transpilable. Compiler scope can have a folder icon, I guess, in the LSP. All right. Well, I mean, let's see what's going to happen in hello here. So current scope is a compiler scope. Okay, so that works, but then over here, compiler scope doesn't have fields, right? And that's where we handle it differently. If I'm trying to get a field of a compiler scope, then it's just going to refer to like this existing symbol or whatever. So it is when I'm having in the core syntax of a field dot. Is that what I call it? Dot. Okay, sure. Object field. Yeah, so I compile the expression object. And I guess like I should know at this point its type. Field is identifier. Expression field. Yeah, over here I match like the type object data type. Type inference variable inferred opt, I guess. Type variable. And then I match this with anything, and then I do this. But if it is a sum inferred type, where the type is t compiler scope, then I do something else. Right? So what do I do here? I evaluate the expression in this case. So object, that object is c dot compiler dot eval expression cast interpreter dot eval c state interpreter object expression, and then let object be object value expect compiler scope. I'm just going to match object shape here with anything else than span expected object to be a compiler scope turn init span c state kind. But if the object shape is value compiler scope, there you go. So now I just need to find the field in this compiler scope, right? Scope dot. There no scope here. How do I find the things normally? If I have a simple identifier, it's state scope find binding. State scope find binding. State scope find binding. From span is span. Where am I supposed to look? The type over here in the bottom. From span string and compiler scope. So string is the field and the compiler scope is a scope. That is my binding, right? And then I just give it an expression binding. Initialized expression. Evaluated expressions is object expression. C state. Once again, there is a syntax error that I need to find over here, I think. Expression is type, expression shape, expression. E-binding. Binding. This expression has type. Types expression shape into expression, but expression was expected of type expression. What do you mean? Init expression. Expression shape. This is expression shape. Which is the last argument here, basically. What do you mean? Oh, span. I forgot the span. That makes sense. When I initialize over here, I must give it a span. Okay, let's see if this works. I have no idea. Could not find foo in scope. So current scope does not have foo. I think it's because this scope is a different one, actually. Than the scope of this module. Potentially, maybe. I'm not sure. Because it's a const. Let's see how am I compiling const. Const let. I'm just evaluating the value expression here. That's... Wait, and the value... Wait, no. And value expression is expression, right? So const let. Is using this value expression. Value expression is compile an expression in the current state. Immediately. Yeah, no, this should be fine. Actually. If I have foo here, then the foo should be available. if I get the scope here correctly. Could not find foo in scope. It's because I'm like getting the wrong scope here, I think. That's the only explanation here. When I have a const, we have a pattern, this thing, and we do const let. I'm interpreting the value, I have a let expression, and I inject the pattern bindings into the current state. Ignore evaluating this. Can I like show all the fields of the current scope or whatever? Current compiler scope, like I want, because this is my scope. Can I like show all the things there? Scope. Scope just has the bindings, right? By string map. Yeah. Can I just do scope dot bindings string map dot iter function iterate what? It has a string. So yeah, field binding, and then just say print current scope dot s field. So I'm just going to have a line for everything there, but there is nothing there, which makes sense why it cannot find it there, right? Find binding, and this is doing it recursively, by the way. Yeah, could not find this in scope. Find binding. It seems like I don't really do recursive scopes yet in this version 2, by the way. But it's okay. Current scope is empty. Maybe I need to like figure out where I'm entering a new scope. Maybe like find these things. So I'm only entering scope using this function. So I'm entering scope in scope, which is parentheses. I'm entering scope in function types, which is not what's happening in a function. In a module. That makes sense. It must be a recursive scope here. Implement syntax, loop, unwindable, target dependent. Yeah, I don't see the issue here. And to like log something maybe. There is inject binding. Oh, inject binding is returning a new scope. Wait, what? That is wrong. Okay, I understand now. It's because I'm actually creating a new scope. Because I did not implement the recursive scopes yet. So like over here, when I am injecting a new field here, this creates a new scope right now, which makes sense if the scope is not recursive. Because yes, foo basically doesn't exist over here. If I do the current scope over here, then it's going to work. There you go. Then I have the foo. That makes sense. Because the scope is not recursive. I cannot refer to foo before it's defined right now. Okay. So in order for this to work, I need to have proper recursive scopes. But current scope is a thing that kind of works. Yeah. Let's have it over here. Current scope. I'll have it like as an example maybe. So the only thing I need to fix is make proper recursive scopes, and then it should be fine. Okay. So compiler state scope, types compiler scope, compiler scope. Compiler scope just has the parent and the bindings right now, but we should have. So yeah, in case it's a recursive scope, we are just going to mutate the bindings then, so it's going to be a mutable thing. And whether it's recursive or not is going to be like another field here, recursive as a boolean. I think that's all that I need. So when I initialize, this is just as a recursive. Initialize recursive. When I enter recursive, when I inject the bindings, this should return the same scope if the scope is recursive, right? Yeah, I just say binding and scope here. I say if scope recursive, then one thing, else the other thing. If it is recursive, then I return then I just return the scope. Oh my god, what did I do? I just return scope, but I do the side effect, which is scope bindings scope bindings string map add binding name binding, and then I return scope like this. And in other case, we return parent. I think even, oh wait, but isn't this scope just a parent scope then? Should just say parent is scope then, because that's what I'm doing. Recursive is false. This creates like a less nestedness, I guess. It's fine, I'll do this. Next, when we have the blank state, we originally do recursive false. When we enter scope, recursive will need to be passed. Recursive. That's what you want. Core syntax. Line 1, 2, 3. Compile state. Yeah, because state, when I'm entering the scope here, this is just the scope. The normal scope is not recursive. Okay, next, over here, I enter scope. This is the function type. I'm pretty sure this is also not recursive. I mean, it's always not recursive by default. This is a function, enter scope, recursive false. So a module is a recursive scope, so I'm going to remove this to do, and we'll actually enter the scope, which is a recursive true. Okay, and then in the cast compiler, just when I initialize the scope, which is not recursive, of course. And over here in the beginning, recursive is false. And this should work maybe now. Let's take a look at the current scope. So this should work now, right? If I restart my language server. Then it actually works. Look at this. There we go. So it also the recursive scope right now doesn't work like actually properly. I'm just saving the reference to the same scope and mutating the bindings here. If I want to have actually mutually recursive functions, I cannot do that yet. Maybe that's really a useful thing to do. With scopes. Yeah, so like technically it's a whip. Let's have an example of mutual recursion. Use std prelude star. Okay, so we just have basically we want to have a function f which calls function g, and we want to have function g which calls function f, right? And this obviously doesn't work because g cannot be found in this scope. So in order to actually do this, we do recursive scopes, which is right now, I think module is the only syntax for that. And this still doesn't work because I need to implement it. Okay. Mm-hmm. Let's also make sure that like print inside f. Over here we say print inside g. Like I want to actually try to run this code, right? We can also have like depth is 0, depth is depth plus 1, depth is depth plus 1. If depth is less than 5, then do this. Else do nothing, I suppose. Or just do depth inside of f, whatever. So that it actually ends at some point. And then just call function f. So this is supposed to work. Right. Let's run examples. Mutual recursion. Inside f, and then g is not found, which makes sense. All right. Depth. So it is a compiler state over here. This is the scope module. So when I'm trying to find the binding, right now I'm just trying to see if the binding is available right now in this scope, right? But the thing is that the binding can be defined later. So we're actually going to wait for the binding to be available, right? We are going to actually wait for it to be available, which means that we need to know if the new bindings are still going to be injected into this potentially. So, and it means that we need to actually like close the scopes too, in addition to opening them. Close scope. I just say scope closed is true. Basically, that's it, which means that scope should have the closed tool in here. Closed is false. Closed is false. Now I need to not forget to close the scopes though. In Rust this was done automatically, I think, by dropping. And here it must be done explicitly. Okay, so I need to like look for all of the openings of the scopes. Yeah, when I inject the binding. Oh wait, yes, I see. Then when I close the scope, and when I inject the binding. Okay, I guess in this case I just close the previous scope because now I'm in the new scope. Dun, 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 dun. Yeah, I just close the current scope. Scope closed is true, but the new scope that I create is not closed anymore. Parenthesis here. Implementing recursive. Oops. Okay, so recursive scope. If this is not found here, then I need to pause the current execution. We're going to use the effect system in a camel here, I guess, right? I'm going to have to pause the execution here. Effect, if it's not found, right? If it's not found, let's just do this. None if not scope recursive. Let's just say none, right? If scope recursive and not scope closed, then I'll do a thing. What thing am I going to do here? I'm not going to return. I'm instead going to try doing this recursively again. Right? I'm just going to loop. But before looping, I need to wait for the update in the scope. Which means that effect dot perform. I need to perform an effect, which means that I need to have an effect here. Effect. We just do this type effect t plus equal something. So like I need to capture the current continuation and like basically invoke it whenever the binding is injected and I will, I guess, save the thing. So I need to like save the continuations inside the scope itself, I think. Yo, Bull City. Hello, hello. How are you doing? I basically need to say scope await update, basically, right? Where await update, we have a scope, and this just returns a unit like this. You activated your Linux recently? How about me? Well, I did not. Still cannot afford it. Good for you that you did it, though. I'm trying to implement recursive scopes using basically async code, which is achieved using effects in OCaml. Here, I need to like figure out how to do that. I did it in Rust before. How do I do it in OCaml though? So I need to invoke the effect here, which is waiting for update, right? So this is called await update, literally. That's the effect, right? Which is an effect which takes as an argument You want to learn a new programming language? I am comfy with Clojure, Java, Python currently. What do you suggest as a hobby? What do you want? Why do you want to learn a new programming language? What do you like building in your programming languages? I don't know. Pick a random one. Rust. Rust is the most loved language, so like it's used by a lot of hobbyists. So you can see if you will love it yourself. C# would be fun to learn, I suppose. I don't know. I think C# is like, I mean, they already know 3 languages. The C# is basically like Java. It's not like much different. Learning just to prevent boredom, like if you want to learn like new concepts, then I think C# is not the way. You learn something, I don't know, like Haskell, for example. Try something that is very different from the languages that you already know. Rust has like this memory model, which is interesting. Haskell, which like it's pure monadic things, is interesting. Clojure is a Lisp as far as I'm aware, so you are a Lisper basically. What other? I guess like out of your languages, none of the languages are low level, so like if you have not delved into the horrors of low level programming, try assembly, C, something like that. Mm-hmm. OCaml as a simpler alternative of functional programming language, I guess. Haskell is a little bit like too different from other programming languages. OCaml is still really like easy to get into. I hate the language, but it's it's a simple one, which is the reason why I don't like it, I guess. But it is yeah, I mean, maybe there is other better alternatives actually these days. I heard good things about F sharp, which is basically OCaml. But I don't know. I never tried it myself. Maybe instead of going into OCaml, going into F sharp makes more sense. I don't know. Yeah, Haskell Rust. Those are good choices. Mm. All right, so effect await update of the scope is going to be an effect which is doing like scope, which is taking a scope as an argument and returns unit. Yeah. Await update. That's literally what I'm doing here, right? Just effect perform await update scope. I think that's what I do. I don't have this as a separate function. Activate Linux. Just noticed it now. Yeah, I'm broke. And you just noticed that I cannot even afford a Linux license. All right. So yeah, effects can only be performed if we have the handler installed. So who is going to install the handler? That's the question. It should be installed whenever I'm inside the recursive scope, actually. Right? Because that's when I'm trying to perform the effect. So whenever I'm opening a recursive scope, if any code inside is trying to wait for its update, no, I think I need like a fork function, you know, like I need a fork function, which takes a function f unit into unit. So this is just something that I want to do. And then this fork is something that can await for the updates. Yeah, I think. So this should be try f with effect await update scope. Then we do something. With effect. Oh, it's because this scope and continuation, right? Because effects have the continuations. So whenever this happens, I need to store this continuation inside the scope. So that I can continue this code to run whenever the variable is going to be defined. Or whenever we close the scope, I guess. Scope closed is true. Notify update scope. And when I inject the binding, I also yeah, I also over here notify update scope, and then we have notify update. Which is going to call all of these stored continuations, I think. So it means that scope must have the waiting for updates. I'm just going to have a list of like functions that we're going to invoke on update, I guess. Submir, Unreal Engine 5. Activate Linux, please. Can you give me the money to buy the license? On update, just unit into unit list. So just a list of things to do on update. How much you need? I heard it's expensive. I need $1 billion. Do you have that? So when I have a notify update, this is literally very easy. We just have a scope on update. It's going to be empty list. But before we do that, we say let fs is a scope on update. And then after that, we do fs list iterate function f. So we just apply all the functions inside of the list. And then whenever we fork, this is where I need to store the continuation inside the scope, right? So scope on update is going to be scope on update plus this new function, which is going to say effect continue. Okay. Continue with the unit value. There you go. I think that's all that I need. Right? So now I just need to, but now I need to fork in proper places. If I try running right now, it's going to say like unhandled effect. Right? Yeah, we have unhandled await update effect. So I can only do this inside forking. And the main place where we do that is something like the way I was doing it before is just the bodies of the functions, because the bodies of the functions can be compiled like later, so we store them to be compiled later. Yeah, that's it basically. So let's take a look. We have core syntax function. So this is the body of the function, which is going to be compiled, right? But that's what I want. I want to compile the body of the function only later, right? So an expression that is a function must have the body, which is like a maybe compiled function or something. Or did I have it before? Let me check a look. GitHub, Slang. In the old Rust version, I'm pretty sure. Function is just has the maybe compiled function. Yeah, I mean, I think that's what I do here. So expression function has the argument body. And evaluated result. Let's see. I mean, this is the compiled function. This is a compiled function. Right? And then we have a maybe compiled function is going to just have a mutable compiled, which is compiled function option. And then expression function is something that has compiled maybe compiled function. So we have a function compiled. We have the like compiled.compiled then. I think expression function is literally going to be just a maybe compiled function basically. So we have a compiled here, and then we say like match compiled with sum. Then we do that. And if the function is not compiled, then I print that it's a function that is not compiled yet. Function not compiled. Hmm. Yeah, but a value function, because so value function is also has the definition, which is an expression function, which is maybe not a compiled function yet, right? So how do we know what is its type? Which I think Maybe compiled function. What is a maybe compiled function? Did I store the type there? Maybe compiled function. Cannot even find it. Let's open that here. Tempcast, I guess. Maybe compiled function. Maybe compiled function is the spawned var compiled function. Yeah, no. But how do I store the type then? Is it stored inside of a value? Num value shape. If I have the function, then it's a function which has a captured thing and compiled. Wait, what? What's the function type of? Function type of a value then? Get the type of this value. A value shape, yeah, over here. If I have a function, then type shape function. Oh, it's because, wait. F. It's a typed function. Yeah, so I have a typed function which has the function inside. Okay. It's all a little weird. Value function. Definition. Typed function. Okay, so I just store the type here, right? Type is a is type function, right? What's the argument? What's the result? I mean, sure. I guess that's what I do. So when I get the type of the function, I just have the type here already. It's type function type, right? Like this. Okay. So when I try to create a function from a definition, this is a maybe compiled function, right? I'm just going to create a type, and once the function is compiled, we are going to assert that the types are the same. Is that how I did it before? I have expression function. Oh. That's the transpiler. Expression function. There is no such thing. Expression. Over here. Sign expression. Expression. Yeah, this is the expression function. Wait, expression function has the type inside already? Okay. I guess that makes sense. So expression function has definition and type. Then We have definition and type here. And we just capture the scope here in addition. Value function, no, expression function. So expression function is not this. It has definition, and it also has the type, which is a function type. Type function. Function. Definition is compiled like this. Interpreter common. So definition is not expression, it's a maybe compiled function then, right? Like this. Okay. So if I'm trying to call a function, in order to call a function, the function must be compiled already, right? Yeah. So I need to say that definition is await compiled definition, basically. And await compiled is f, which is maybe compiled function, which returns a compiled function. Why can I not go to the definition here? Valdigo, hello, hello. Good luck, have fun on the programming language. Well, the fun is happening for sure. I'm currently implementing basically like a lazy compilation of the functions so that we can compile them later. Have fun or have a fun? Well, right now I'm working on a fence. Hello, bad cop. I think for now, let's just have a to-do here. If f compiled, I mean, I'm going to just match f compiled with none, and then I'm just going to panic here. Fail with function not compiled. Some compiled, then I return compiled. There we go. 35 dead joke. Have fun or have a fun. Have a lot of child processes. That's about it. Are you sure that your child process, that your children are not zombies? That's forked up. All right. Yeah, that's fine. Await compiled. Compiler init. Over here, when I'm initializing the expression, which is a function, it has a type. Okay. Yeah, we have just a type and other things here. The type is the function type here, like this. Okay. And then core syntax. So when I am actually creating a function, Now I don't compile it immediately, but I instead fork it. How do I fork it here? I say state scope fork function, where I say let body be this. We create the result expression. I create the maybe compiled function. So definition is of type maybe compiled function is compiled is none. That's what we begin with. And then once it's compiled over here, I say that definition compiled is now sum over here in the end. And we create a function with this definition. And we also need to store the type here. Right? So type function is argument. So we start with new not inferred types. Right? But once it's compiled, we say that the types are these types. So I say that definition, no, I say that type argument is the type of argument here, right? Argument is compiled pattern. Wait, hold on. Do I even need to compile the pattern here? Inject pattern bindings. Yeah, because I entered the scope here. That's also is happening all inside here, right? I'm miscoding from balcony. Balconies are in balcons are too open for this. They don't have any incentive. Make them warm and isolated. Yeah, it's basically like a room, a separate room for me. I don't even think about it as a balcony. But yeah, we say just type argument. I say inference type expect inferred as. Yeah, I say like type argument expected to be inferred as argument data type, I think. And then the span, where we would report the error. Is going to be arg data span, I guess. Okay, and then the type result inference type expect inferred as span is going to be body data span as body data type. We just do this. Okay, and this is another function here when I implement the syntax. I think I will just going to compile it here directly, maybe. It's fine. And maybe fork here too. State scope fork function this into that. And then return a function. definition and type. Let definition be maybe compiled function is compiled is none. I feel like I'm copy pasting things here. But okay, and then type function, type is type new not inferred, result is type new not inferred. No, this is literally copy pasting. Hold on, I don't want that to be copy pasted, right? This is an expression. I guess the difference is the pattern here. It's not exactly the same. Fine. I'll keep it to do here. To do maybe reduce copy pasta here and ln function. And now the syntax error. I love figuring this out. In what was missing? Definition compiled is some type. This is argument. And then yeah, like I copy paste here, which is wrong. I'll fix that later, maybe. That definition is await compiled. Definition probably should not be inside the interpreter. Maybe this function, I don't know. If we have the LSP and we have a function, now this is a function. Okay. We have a definition. Type here. I'm going to match definition compiled with some. And we do that. And then I don't do anything. Okay, it works. I mean, it compiles. If it compiles, it doesn't mean that it works yet, right? Because we still have this problem that we have unhandled await update. Which Which is actually weird. Hold on. Why is it like that? Did I not? Because I forked it now, right? When I was compiling the function. Let me see. Maybe there is still something. Yeah, over here actually we have F, but F is already available, so it should be fine. G. So this is when I am compiling the const, compiling the pattern. Wait, while compiling this string identifier. This is it, right? It's a string here. Okay, so you are saying that string, this thing, is not available yet in path, but it should be available, right? Oh, because it's in the parent scope. That's right. This is a recursive scope, and we need to like, okay, so here's how the resolution works. Because this is a module, the string is an identifier that is potentially going to be introduced here, right? Like string is 1 to 3 here, right? Then this string would refer to this string, but it actually is it's supposed to refer to the thing from the parent scope, which is where the path is included from. So we need to wait for this scope to actually close. And also, it means that over here, when I'm specifying this type, this type that I'm specifying here, maybe it's like all the type annotations. All the type annotations also should be forked, I think. Like I can evaluate this thing in the later. Maybe type description, type ascribe over here. So when I do a type ascribe, I do all of these things. We update the data with the type ascription. But now it means that I need to actually like mutate the thing if I want that. Wait, why do I even need type ascription here? Why is this a field? Just so that I cannot type ascribe twice. Does it matter? Type ascription. Maybe this can be a mutable field. This is just an expression. It's more like evaluated expressions. I need to like mutate that too. Or something. But yeah, we do this in the background. Which means state scope fork. So I'm compiling this expression in the background. No, I still need to compile the original expression here. It's the type annotation. Expected type and expected type. This is the thing that I need to do in the background. Like that. Then now it means that the expected type of expression is this. Expression data. So I just returned the expression here, by the way, right? But then I do this. Data. This is like expression data, right? And then I say expression data dot type description is some expected type expression. So I mutate it later. And there is a syntax error again. Where is it? I don't see it. Why is this camel not a crab? Because of compilation times, camel is fast and crab is slow to compile. And that's kind of important for me here, apparently. Because it was a crab earlier, but it's no longer. So, this project was written in Rust before. I have this, this is my old Rust version. There we go. You wanted a crab? Here you go. This is a crab on the screen right now. You do cargo run here, and this is the old version. 2 plus 2, and you have a 4. There you go. See? It was working before. But I don't know if I can show this easily. Let's try like I don't know. Let's try renaming this from unwind to unwind 2, for example. Right? And then see how quickly is it going to rebuild. I don't know if like renaming a type is going to like delete a bunch of things. It seems like it's going already really slow, you see? Like all that I did right now is I renamed a type. And it's already running for more than 10 seconds. And this is a debug build, that's not a release build. My project here is really big. This is going to take probably like around 50 seconds, if I was to guess. This is a big project. It's the reason for this is because it's like a single big crate. Splitting it into multiple crates is like really difficult. So when I have this, I cannot work on the language really quickly, right? I want to work on the language quickly. If not the compilation time, I would continue be working in Rust. But like, I'm trying to make a prototype, and I want to be able to move fast. I wish Rust had like the option that is somehow doing this quicker, but yeah, it takes a minute for this simple change. You see? That's the problem. Hopefully that answers why. Now I know how to show it. I can just rename the thing in an enum. Okay. Now I know. Other than that, Rust is a beautiful language. I love it. Actually, like this project is the project which I have the compilation issues in. This game that you see in the top right is also written in Rust, and I don't have the compilation problems there. It still is like relatively slow to compile, but I think when I'm working on the game, it's like recompiling maybe like for 20 seconds is also like fine. Right, but a minute for a small change like that, that's too much a little bit. Yeah, like I just don't feel the issue as much when I'm working on the game, but when I'm working on the programming language here, I do. And like the solution usually is to like use less generics, less smaller crates, like split your big crate into like multiple smaller ones and stuff. But it's a lot of work to do that. I would like to just write the code and not think about the details of how to make the compiler fast. So for that reason, for example, in my language, if we think about how do we make it fast when we make our own custom language, right? Well, this language is going to be interpreted as one of the most important options. So we can like we can immediately start kind of executing the program and compile as we go. Have a JIT compiler or whatever. There are not a lot of examples of languages that are both compiled and scripted, I guess, and interpreted. But there are interpreters for C, and technically it is possible to have an interpreter for Rust. But they are just focusing on other things, I guess. Also, like in Rust, there is a lot of like static dispatch of things. There is a lot of monomorphization happening, which is why the compiler is slow. But if there was like a switch, which basically turns your like that doesn't lead to code duplication when the code is generic somehow, would be nice. Like the original Camel is fast is because it doesn't do monomorphization. When you have a generic function, it still is compiling it only once and not like 1,000 times like Rust. But there are other issues because of that, I guess. Anyway, I need to continue here. Core syntax. The syntax issue is line 474. Oh, this is not closed, I see. And to close the parentheses over here. I wonder if there is a proper reason as to why DIN compatibility in Rust requires function to not be generic. Raymarch, hello. Why DIN compatibility in Rust requires function to not be generic? Well, I mean, DIN is a specific thing, and how are you imagining a generic function that takes a DIN? Basically, what I want is like a simple switch between like impl trait and DIN trait, right? I guess you kind of can do that already, maybe. With your own macro. You have a macro which is like impl or din, and you use that. Maybe that could help with but I would just go for din everywhere I could, but it's not always possible to just use the din traits. Can the compiler have make many vtables for one trait and have more complex runtime info? I guess maybe somehow could be done. I don't know. For example, clone. Clone cannot be turned into a din trait at all. But why exactly? Let me refresh my memory. Clone din clone. There's a crate for it, right? I don't remember why. Wait, I don't remember why. I'm too lazy to think. Let's ask ChatGPT. Why in Rust clone cannot be done? Is it because of self? Because it demands self-sized. Yeah, but why? Oh, yeah, it demands self-sized. That makes sense. Yeah. Yeah, that makes sense. Because like, what is the output, right? Of your clone method. That's why the din clone is cloning into a box, basically. If you clone into a box, then you can have the thing. I mean, it makes sense, right? And boxing is a pretty big overhead, right? But the thing is, so like if we want to have a language that is like I think in the background, like I think semantically Rust could be like have like the same semantics, but in the back end, like there would be a thing that like just boxes it automatically, I guess, which has a little bit of overhead in runtime, but it compiles faster. Something like that, I guess, is my idea. So like sacrifice some performance for the sake of compilation times, right? But that means that like you need support like 2 modes now. Like it makes sense that they don't do it. Hello, Zadik Spix and Penguin. 20 seconds is okay compilation time? Question mark. There is C++ live extension for VS Code that compiles in 1 second and 2 seconds. Considered too long. Well, it depends on how big your project is. C++ 20 seconds is definitely okay, I think. Usually. C++ 1 minute probably would be okay. Am I right, Raymarch? When Raymarch has a lot of experience with C++, a lot more than I have, I think, right? What were your compilation times in C++? You got your engine down to 8 seconds? Nice. Extensive tricks with forward declaration and stuff. Have you tried this like C++ leave extension for VS Code? Or how does it magically make your code compile faster? Because it's like live reloading it? I'm expecting because it's live, it's for real-time compilation and feedback. Real-time compilation. Build C++ code in real time by executing C++ live. That's just building it in... Yeah, no. 1 second and 2 seconds is considered too long for sure. Like if you want to have a like live feedback, it's like the Rust analyzer is compiling your code in the background when you're working in VS Code. Like it's the same thing, I'm assuming. And like right now, my OCaml is compiling stuff in the background so that I can have errors shown in the editor. It's like the same thing. It creates PCH, and you can work really fast. What's PCH? Public Clearinghouse? Precompiled headers? I don't know. If there was a way to have C++ compiled faster, wouldn't like, is this some secret knowledge that only you possess? Because as far as I, like, that's the first time I heard about it. Is this something like new? I think it just depends on the program that you're writing. Like, if I run a hello world, then it's going to recompile in Rust in like half a second, like, or even less than that, or whatever. I'm not even going to notice it. You can press Ctrl Shift X in VS Code, type C++ live, and watch the video. This one, live C++ experience by the Segfault Survivor. I mean, but this video is made for a simple, small project. That's what I'm talking about. When your project is small, it's going to be really fast, even in Rust. And in C++. This is 40 lines of code, probably, and that's all. It depends, like, it will not always be 1 second, right? If your project is huge, there's no way. They somehow, it's for any size, I don't believe it. I don't trust it. There is no way. Is your engine open source, Raymarch? Can you try it for your project and see if it was 1 second? Somehow it makes the C++ compiler just go brr, right? All right, what am I doing here? I'm having unhandled await update here. Yeah. Remember now. Let me go take a bathroom break. All right, yeah. So what I'm doing is I'm trying to yeah, this time this over here, int32 is is a thing that is potentially in this scope. So like when I'm compiling this thing, I'm looking for the integer symbol, but I know that I'm inside a recursive scope, so I should wait for the entire thing. Because int32 potentially somewhere else. Hello, Nerdzel. I can also like do right now, like this thing where if there is like a default handler, which like says that I should not be waiting, basically. Await update. Await update. Like I think maybe this returns a boolean then, and if this returns if this returns false, then I'm just going to I guess I do like over here, like and effect perform. So otherwise I just go to the parent. Something like this. And when we fork, when we actually got the update, we do return true here. Am I not in this file? Like, why am I being shown this error? Oh, it's success. Okay, it's because I scrolled the window, I guess. Yeah, so now I'm just going to have the handle effects. I'm just going to have a global effect handler. Which is going to say that if there is an unhandled compiler state compiler scope await update, then I'm just going to effect continue. Okay, false. Full scope is state scope. Maybe let's try that. So now it's going to say that function is not compiled. But which function is not compiled? I feel like await compiled. Maybe await compiled. Wait compiled. Like if I'm trying to call a function that's not compiled, I want to return an error, I think. Better errors next stream. No, I'm going to do it right now. Like we want to not panic at all, right? We want to, even if I try to call the function that's not compiled, I just want to return an error. We want to never exit, right? We want to always continue with some value. I just give it an error value here. So await compiled is actually going to return an option. Is that it? Because like failed to compile, so it's an option or whatever, right? And then over here I say option unwrapper else return. I mean, and also I say that if f compiled option is none. Yeah, and then I also over here I give it the span. So I do error span function is not compiled. And over here I return shape the error. Which is value. So I do here with return. The transpiler I will panic for now. Unbound record data. Wait, what? Oh, it's a value. I don't have the value here. Okay, let's just do span fake. We do. Wait, span fake. And spiling value. But maybe we should store like in the function where it is defined. Where was it defined? Okay, function is not compiled at mutual recursion. Yeah, over here. So it says that this function is not compiled. But why? This actually makes sense. Wait, does it make sense? No, this doesn't actually make sense, right? Because this function is supposed to be compiled as soon as I define the g. Here, right? Yeah, it seems like I cannot hover it. That's because it's not compiled. Okay. Like, in order for me to be able to compile the body of the function, I need to wait for the definition of g. And since the g has been defined here, it must be compiled at this point. Well, I mean, especially since I like at runtime, this should be compiled for sure. What about the other examples though? Can I try like hello world? Is hello world still working? It does. Okay. I did not break that at least. It seems like function g is also not compiled. Wait a second. Fork. I'm creating a function, I'm forking here. Compiling this function, but it should like happen immediately. Shouldn't it? Oh wait, I know why. It's the same thing, I think. Here is the problem. I'm not using just the G here, right? I'm also using depth, or I'm using print. Yeah, I guess it's the print. So where is print defined? Because print can be potentially defined later in the scope. Which means that in order for me to figure out what print are we referring to, and to wait for this to be closed, I am not closing my scopes yet. So I need to close the scopes manually now. Enter. I need to do like, I need to find all the enter scopes. Like in the compiler, this state enters the scope. In the core syntax. I mean, technically I don't need to close the non-recursive scopes. So maybe like this is the only one that I need to do, the module. Then we compile this definition, and once this one is compiled, I just say C state scope close. That's what I need to do. And another recursive scope. This is when I'm compiling a function. Oh wait, no. This is the only recursive scope, the module. Yeah, never mind. This is the only scope. This is the only place where I need to close it, actually. Let's see if this makes it work. It doesn't. Okay. Let's see what am I actually waiting for. What is not defined yet? Right? What am I waiting for? Await update. Let find in parent is this. Find in parent. Find in parent. Over here, I want to say log info. Waiting for symbol in recursive scope, and the symbol is identifier. Yeah, so that's what's happening. I'm waiting for print. You should always write header only, never separate declarations from definitions, and use VS Code Live to make incremental compilation that takes 1 second. So it's not just the C++ Live that so it doesn't work for any project. It only works for projects which are header only and don't separate declaration from definitions, right? That's a lot more than just it works for any project. So function is not compiled because waiting for print symbol in recursive scope. But actually calling the function only happens in runtime, where the scope is supposed to be closed already, right? So I'm still waiting for it. But why would I still be waiting for it, right? Close. Closed is true. Oh, over here. Hold on. Over here, closed is true. Notify update. Close scope. I mean, it doesn't matter. Probably it's the same thing. Yeah, that makes sense because like this is a not recursive scope that I am closing here. Anyway, notify update. We'll just call all of those. Scope on update is this. Log here. Waited. Right, so I'm waiting, waited, waiting, waited, waiting, waited. LP Gorley. I want like with the scopes to have like I don't have the spans attached to the scopes right now. So I cannot do more logging than this. But let me see. Waiting, waited, waiting, waited, waiting, waited. Log. Looking for this. Waiting for print symbol and recursive scope. Looking for F. F. And just like figure out how to debug this. What's going wrong? Attach the spans to scopes to figure out in what scopes am I looking for currently. And it said waited for print, waited for print. So I waited 3 times. Why did I wait 3 times? That actually makes sense, right? So I'm looking for this print. I'm assuming, actually, there's 2 prints that I'm waiting for. You know what? Let's try a simpler thing. Let's comment this, and let's just say, let f be this into print hello. And then I want to call function f. Use steady prelude. Let's try this simpler example. Oh, wait, this actually works. Oh, it works because it's not a recursive one. Yeah. We need to do module here. Wait, this also works. Wait, what? Okay. Big language development. When will you guys make a language tree-sitter style so it compiles only those letters user is currently typing? That's called incremental compilation. Yeah. I'm probably going to look into that in the next rewrite. Why does this work? Now that makes not a lot of sense to me. Or what if I open another oh wait, I know why. It's because the print, because I used it here. That's why. I used it here, so I injected the binding into this scope itself. I need to have the use outside. That makes sense. There we go. Now the function is not compiled, right? So I'm waiting for print, and I waited for it once, right? So why did I wait for it once? Because the only event happened, which is me closing this thing. And since I closed this thing, since I waited, for this, now I'm going to look for print. And then it says waiting again. So that makes no sense because like the update was that I closed the scope. Right? The update was that I closed the scope. Notify the update. Print closed. And I don't mean just parsing, CodeGen, linking, everything should be 01. It cannot be 01 because it cannot always be 01 because when you change a thing, a small thing in your code, there are other things that depend on it. So it is not going to be 01, but it should be O of the dependence. It's not amortized even. It's like it's basically your program is like a graph, you know. Your program is like a graph. So like over here, this is like some character, this is some other character, this is some other character, and like this over here is like is the like compiled function that depends on this character and this character, right? Which means that when you have changed in your editor this character, it means that this function also needs to be recompiled, right? And then there's something else that is depending on this function. So when you change this character, you need to recompile this function, and then something else that depends on this function, right? I mean, if there is like yeah. I mean, like it depends on like what you change, right? Sometimes a change in this in a function results in a change in something else, right? So like there's a graph basically, right? But right now I'm recompiling everything, like even those things that are completely irrelevant. That's true. But you cannot make it O1, I'm pretty sure. Not the whole function, but a tiny bit was modified. Well, I mean, it depends on the bit of the function, right? If you change, like, for example, the type of the function or the name of the function, right? But so like when you change the name of the function, for example, that function is not available in the other place where you are calling the function anymore, right? So that other place needs to be like invalidated, right? That's what I'm talking about. If you're like changing a little bit in the body of the function, like a string, then like that doesn't really need to change anything in the places where you call the function, I guess. Renaming should not trigger recompilation at all. I'm not sure. It's not about renaming. It's a renaming, but only in one place. It's renaming in the definition, but not in the not in the call site, right? When that happens, it means that it actually changes things, and you can like swap two functions for each other or whatever, right? Like, you know, when I'm coding, sometimes I have a function f, and then I want to, like, instead of commenting it out, I'm just going to rename this function temporarily to f2 and have like a stub implementation, right? That's going to trigger recompilation because now I'm referring to another function or whatever. But yeah. Also, I'm not a real compiler developer. I'm just playing around or whatever, you know. So maybe that's a task for some real programmers of programming languages. This is my first programming language. I'm just figuring it out. Looking out for F. Closed. Wait. It's closed. But what was the other update then? Notify update over here. Print injected binding name. Yeah, so I injected F, so I'm no longer waiting for this to be printed. Looking for print, I'm waiting. Oh wait, so it's closed, but then it's not continuing. Okay, that's the problem, I guess. Okay, I see. The notify update did not work. Print. Number waiters. Scope. List length. Oops. Oh, JPix. Thanks for the prime. And if the other place has an alternative identifier that matches the previous name of the function, that could cascade into different type signatures of the result types, which could change another thing and another. Yeah. Okay, it says numbers of waiters 0. Waiting for print in recursive scope. Waiting for this in recursive scope. So I have done that. I'm losing the thing, you know? let me see here. Print registering waiter. So it says waiting, so I'm registering waiter, and it's closed, and number of waiters is 0, which makes no sense. Do I have scope? Maybe I should at least have scope IDs. Let's have ID here. ID. ID. ID is ID gen. Closed. ID print scope ID. In ID print scope ID. Your mind. Wait, what? What do you mean your mind? Registration waiter. 4. I'm losing the thing. My mind. No, I'm losing the so like I'm registering like the continuation to continue working after the update has happened, you know. This is like I'm writing like an async scheduler or whatever. Here because we are doing async compilation now. Oh no, wait, I'm waiting in 596, but I closed 595. I think I can see the issue then. I think I see the issue actually. Hold on. Dot close. For syntax. State scope close over here. I see. I see the problem. So I created a new scope, and I assigned it to a new state. But I closed the previous state. I closed the wrong scope here. I need to do not C state, but just state. There we go. I figured it out. Okay, and then we have the hello. It's working. Okay, let me remove println here. Println. It's going to work right now. Mutual recursion. Looking for. Remove this. Remove that. Remove that. Okay, hello. So let's try mutual recursion again. We just use this actual program. Okay, there we go. Look, this works. We actually have recursive scope and mutual recursion of the functions. That's great. Okay. That's cool. If I restart the language server, I think I should be able to like go to the definition of G here. Yeah, there you go. Nice. What about the other things? Yes, a number. Still works. Okay. Nice. Recursive scopes, I think, is done. Like, it's not exactly like done. There's still things that could be improved, but I guess good enough for now. Okay, and by the way, I was doing all of that because I was trying to... Wait, what was it? Why did I even need the recursive scopes originally? I was writing something in the standard library that's recursive? Or no? I don't even remember anymore. Advent of code day 1. This is still just reading the lines. I don't remember why I needed it. Oh, I remember now. It's because the STD. Okay. So that's what I was trying to like improve the way I'm writing the standard library. Because this over here, native plus, the reason it's like this and not I+1 is because I+1 is syntax sugar. Once again, for std op-add. But since since that code is inside of the std, it doesn't know what std is. So we implemented these new things. Yeah, std is not found over here, right? So implemented this new thing that is called current scope. So I can save the current compiler scope into a variable and then like query that thing. So basically, when I'm inside the std, when I'm defining it, now over here, I'm going to say that std is just current scope. And so now I should be able to refer to this, I think, potentially. Seems like it actually works. So let's just rewrite this. I'm also wondering if I can do over here native equals. Can I do that? Let's try. So target name is equal to interpreter. Does this work? Type check failed. Int is not string at fake to do. Okay. This is a little weird. Maybe I need parentheses here. No. Why would it? Oh wait, it's because equal. Okay, it's because right now the comparison operators are only working for integers because I don't have the generics yet. Okay, that makes sense. So I cannot replace this equal, but I can replace the I+1 here like this. Also, this equal can be replaced because these are integers. This should be 0 minus 1 because I don't have unary minus yet. 0 minus 1. C is C at I. Wait, something went wrong here. Oh, my Rust analyze my cast analyzer just crashed. C type check failed. Char is not integer. Oh wait, that doesn't work. So I cannot compare like chars for equality either. I cannot replace this yet. That's not an integer, that's a char. I guess I really need the generics next. Shouldn't be too difficult though. Yeah, I cannot do C equals /n unless I use a different symbol for that. I mean, or can I? Hold on. What is the equal? I can do this. Or can I? No, I cannot. Hold on. Because we had like generic as like just a function, right? If I have let generic let foo. I mean, we want like the ID function, right? What is the ID function? Is t into x t into X, right? So this is a function that takes type and returns error into error. But can I say ID 123? Type check failed. Type is not int32. Yeah, so ID int32 123, right? There we go. So now this is of type int. But if what if I say now ID string hello? Then this doesn't work because this has already been inferred to be int, which is wrong. But that's because I have compiled this once. Yeah. I need like this needs proper dependent types. Okay. Yes. Okay. I think I can make this work next time though. Probably. Use math. Implement dependent types. It's probably like not going to be like proper dependent types. I don't know. But we'll see. That's going to be next time, though, not right now. Use math ops inside std. Next time, dependent types, generics. Because like generic is literally just dependent types. That's like if you look at dependent types, where would I? Multimodal type theory? No, that's not what I want. I think dependent types. There is the example in the Wikipedia, I guess. Yeah, so a function whose type of return value varies on its argument is the dependent function, right? And that's why this is a dependent type here. Because the type of this function that I'm returning is depending on the argument, right? Because if this first argument is int32, then the result of ID int32 should be int32 into int32, and like that. So that's dependent types. Right. Which is how we do generics. I don't know what I wanted to look up. Let me just in the stream here, because I did everything I wanted today, I think. So yeah, there's 10 more days until Advent of Code 2025, I guess. I think we should be able to do it. Camelers around. Yep. You want to use your own language for it? Yeah. Because like it's basically like Advent of Code is giving me something to write, something not too complex, right? So that I can test the language that it actually works. I already did it a year ago, but it has been rewritten. A couple times since then. This time we have the editor support. And I just need to add a couple language features, and it's going to be pretty nice, I think. Mainly just the generics and the sum types, I think. This is the only two things that are missing now. Maybe. And then like just implement the standard library more. And let's see here, custom game engine coding C++.
No.
Build completed and took 13 seconds. This person does not use the C++ Live. It's more than 1 second. But custom engines are fun. Let's go here. See you guys next time. Bye. Just started the coffee time. Oh, but the raid already went. Okay. Oops.